Okay, so before the break, hopefully you have your notebooks, you can look and review this paper that we did with symmetries and diagonals of quadrilaterals. So here we found reflectional symmetry and rotational symmetry that would essentially get the figure to land on top of itself. So what we're going to do today is take what we did here a step further. So if we look, it's going to kind of help us review here a little bit just for this first one, rhombus, to help us get an idea. So it says, what are the lines of symmetry for a rhombus? Draw them on your rhombus and list them below. So here's our rhombus. We're going to draw them, and if we remember, the diagonals on a rhombus happen to be lines of symmetry. So it doesn't have to be perfect, but here are lines of symmetry that are going to get the figure to land on top of itself. So to label them, we're going to say from A to C, and then to say that we've drawn a little line segment, we put a dash above it like that. And then D to B, so we'll put DB with a dash. So this is just saying this is a line segment. From A to C, line segment from D to B. Okay, what are the angles of rotation for a rhombus? Okay, so if we remember, going 90 degrees isn't going to line it up. We actually have to go 180 degrees or 360. So this should all be from 6.5. Okay, so now what we're going to try and do is prove some different things about the quadrilateral. So a rhombus, by definition, has 4 congruent sides. So if we draw a rhombus here, and I'm even going to label these A, B, C, and D. Okay, so here's our rhombus. And we know that all sides are congruent based on the definition, okay? But we want to see, can we prove that, and can we prove some other things about the shape using transformations? So notice it says here, prove that in a rhombus opposite angles are congruent. Okay, so opposite angles are going to be D and B. They're opposite from each other, and A and C. And notice here, this symbol right here means angle. So the line up here meant line segment. This means angle. So they want us to prove that angle A is congruent to angle C. So remember, things are congruent if we can perform a transformation to get them to land exactly on top of each other. And if they match exactly, they're going to be congruent. So we need to figure out, how can I get angle A to land on angle C? Okay, how can I get angle A to land on angle C? Using transformations. Now we're going to look, this was really helpful. So we knew that the lines of symmetry here were this going this way, right? This line here, or this line going this way, right? So we know that those two things are going to get the figure to land on top of itself. We also know that we've got some degrees of rotation, so I can rotate my figure 180 degrees and it will land on top of itself again, just like that. So we're going to use those to prove these things. So we're going to say, let's take this one for example. I'm going to do this one using reflectional symmetry. So it wants us to prove that angle A is congruent to angle C. So notice here's angle A. Okay, and I'm just going to mark it with this orange. So we're going to, if I reflect it across, notice if I reflect it across DB, what happens to angle A? Notice that it lands right on top of angle C. So we can say that. We can say reflect angle A over, remember when we give reflection we need to give a line, so I'm going to define that line as DB. So reflect angle A over DB. And what happens when I do that? Angle A lands on angle C, so angle A is congruent to angle C. So remember that this symbol right here means congruent, or the exact same. Okay, so through that, you see I used reflectional symmetry. Angle A has landed on top of angle C. So I reflected it over DB. It lands on angle C. So they're congruent because they matched up exactly. Okay? Then it wants us to prove that angle D, so here, is congruent to angle B. So what we're going to do, I'm going to use rotational symmetry for this one. So let's label this center point actually. So this, we've got A, B, C, D. So let's label this E. So that center point, because we need to define a center of rotation. So I'm going to say, if we rotate, we're going from angle D. So here's angle D. Here's our buddy. We need to rotate it around E, or the center of the figure. How many degrees? So if we went 90 and then 180, what happened? Angle D landed on angle B exactly, so they're going to be the exact same. They're going to be congruent because of rotational symmetry. If I rotate this guy, does that make sense? So we're going to say rotate angle D. How many degrees? 180. Now remember, when we go 180 degrees, the direction doesn't matter. So I'm going to put clockwise just because that's what I did, but it's not necessary. So I'm going to go rotate angle D 180 degrees counter or clockwise around point E. So I've labeled E. So around point E, and then what happened? Angle D landed on angle B, so angle D is congruent to angle B. And now we've proved both of those through the symmetry that exists. So notice we've got through reflection and rotational symmetry. Okay? So that is just the beginning. Let's see if we can try and do another one of these. So let's jump to number 5. Oh, this is going to be hard to see. Okay. Let's see if we can fix this. Okay. So it says, number 5, prove that diagonals of a rhombus bisect. Now, bisect means to cut in half equally. So if I've got a line and something like a dot cuts it in half equally, that this side is equal to that side, then I have bisected it. Okay, so it means to cut in half equally. So prove that the diagonals of a rhombus bisect, or cut in half equally, the angles. So here's the diagonals. And they want to know, does it cut this angle right here in half? So is this angle, we can use that as some, is this angle right here congruent to this angle right here? Are these two angles the same? Okay, so that's what this is asking. Now again, it has us label the center point E, which we already did. Okay, so now we can follow, the way that we read this is the angle, remember? And it wants us to follow ADE. So we're going to go from A to D to E. So this is actually talking about this angle right here. Okay, they want to know, does that angle meet EDC? So EDC meet this angle right here. So they want to know, can we prove that this orange angle is the same as that blue angle? So again, we're going to go and use our patty paper here and think about, okay, how could I get this orange angle to land on top of this blue angle? Okay, how can I do that? Now we can think of, if we rotate, that's not really going to help us because that angle is going to stay in the same place. So maybe we can try our reflectional symmetry. What happens there is that our two angles have now landed right on top of each other. Okay, so we can come to here and say reflect angle ADE, that was our center point there, over, and remember we need to define our line, over DB. And then what happened when we did that? angle ADE landed on angle EDC, so they're congruent. Okay, and this one's going to follow along the same lines. So what I would like you to do is go through and use patty paper if you need to, some colored pencils or something to keep track of where your points are, where different things are landing. And you're going to want to be using either the reflectional symmetry, so lines of symmetry within that figure, or the rotational symmetry within the figure to prove these different things. Okay? And you're going to want to go through and do that for the rhombus, the parallelogram, the rectangle, and the square. For the square, you're going to have to pick some attributes. So notice this one said like opposite sides are congruent. So you need to pick an attribute. So you could say opposite sides are congruent. Okay, so I need to prove that AB is congruent to DC. Okay, so on this one you have to pick your own attributes, but you're going to be following the same lines as what you did on the others.